Hi, welcome to today's lesson on slope. We are going to talk about slope, mostly how to calculate slope. We'll talk a little bit on how to use it, and then the next lesson we'll put it all together. We'll talk about intercepts, and then we'll put it all together and we'll talk about equations. But for right now, I want to talk about slope, okay? What is slope? Now, we're talking about slope of a line specifically. We could use slope when we're talking about array as well, if you remember our last lesson, but we're really just going to mostly focus on lines. Okay, the slope is the amount of change in y over the change in x. In other words, we're going to use the symbol delta for change. Change of y over change in x. You might have heard this before. We're going to talk about it as rise over run. Okay? So on the graph, we're going to talk about how much it changes going up and down, and then over changes how much it goes left and right. Okay? And that is going to be our slope. And we're going to look at how to find it with a graph, and we're going to look at how to find it with a couple of points. And those two things, they kind of are interchangeable, but it depends on what they present us with. If they present us with a graph, then let's just use the graph. If they present us with the points, we might want to just use the points, and I'll show you how to do that in both cases. So let's look at, I said we start with a graph. So if we have ourselves a graph, okay, we've got ourselves a point right there, making my life easy. Let's put another point there, and there's my line. And I want to know what is the slope. When presented with a graph, I don't think there's a much easier situation for us. Okay, all we have to do to find the slope of a graph is count. And I mean, we're talking simple numbers here, okay? Because we want to know, again, change in y over change in x, or in other words, rise over run. And how do we check that? We just pick any 2 points. That's the beauty of it. Doesn't even matter which ones we pick. As long as we're picking 2 points on the line, it doesn't matter which 2 points we picked. Okay? I'll show you why. I'll show you that in just a second. So I'm going to pick right here. Just going to go from there to there. So what I do is I'm going to check the rise. Now when you're checking rise, you're not on the line. Okay? It's straight up and down, straight right and left. So we're going to go 1, 2. We went up 2. That's the rise. We go over 1. That's the run. 2 divided by 1, our slope is 2. Seems pretty easy, right? We just counted. I said it didn't matter which points we chose. Watch. What happens if I choose these 2 points? I go up 1, 2. Hey, that's our rise. I go over 1. Hey, that's our run. We knew that. Got that. What if I chose these 2 points? I'd go up 1, 2, 3, 4. And then I would run 1, 2. What's 4 divided by 2? Hey, look. It makes absolutely no difference. What if I went backward? I could even go backwards. It won't matter. Watch this. I'm going to go down. 1, 2. When I go down, what do we think when we mean go down? Then that rise would be -2 because we went down. Then we went backwards 1. We went towards the negative on a number line. -1. A negative divided by a negative is positive. It doesn't make any difference which points we choose. We do want to keep that in mind, that up is positive, down is negative, down, okay? To the right is positive, and to the left is negative, just like on a number line. Okay, in fact, if you think about it, this is a number line, and then this is a number line that we've turned like this. so that this is the positives and this is the negatives. Okay? But when it comes to finding slope, how do we do it? We count. Rise over run. It doesn't get much easier. We always would reduce, if possible. If it can be simplified, we simplify it. If it can be turned into a whole number, turn it into a whole number. Don't turn anything into a decimal, okay? I know it's tempting at times when you get things like a half to make it 0.5, but don't do that, because what you want when you see slope is you want a rise and a run. It's like getting directions to a location. If I said, if this is my house and this is your house, and I said, how do I get there? You wouldn't give me you would tell me go up 4 blocks and over 2 blocks. Those are very specific directions and they're followable. Okay, that's why you want to have 2 values for your slope. If you get a whole number, then you just have to remind yourself that the other number is there's always a 1 under it. Whole numbers can always be made into a fraction by putting a 1 under it. Okay, so you don't want to turn it into a decimal. Fractions are fine. In fact, fractions, you will find you won't hate fractions as much as you used to, because here fractions as slope are really easy to use. Okay? Now that's how you do it if they give you a graph. What happens if they give you a couple of points? Okay? And they say, same question though, they'll say, what is the slope? And then they'll give you 2 points, 3, 5, and -1, 2. Now, the first thing I want to mention is, don't make any assumptions based on the points. Okay, don't say, oh, then that obviously is going to be a negative slope because of this point. Don't make that assumption. It's probably not even true. Okay, you might start to figure that out at some point, but don't do that. Okay, now you have 2 options with this. Okay, if the numbers are small, like these, you can always put them on a graph. We know how to plot points. We have -1, comma 2. That's right here. And then 3, comma 5 is right here. And we'll just connect those 2 dots. And now what are we going to do? Same thing we just did. We're going to count. We're going to count our rise. We're going to count our run. So we're just going to go rise over run. And we're just going to pick point. I would just, because I read from left to right, it's just always, I'm always going to do that as my default. So I'm going to rise. 1, 2, 3. 3 is the rise. And then I'm going to run. 1, 2, 3, 4. Okay, there's my slope, 3/4. Okay? I don't need to turn that into a decimal, and in fact, I'm telling you again, don't turn it into a decimal. Leave it as a fraction. It's perfectly fine as a fraction. Okay? If I wanted to know where the next point was on a graph, I would just keep following this slope. I would go up 3 more and over 4 more. And so on. I just keep doing that over and over again, and I would have my eventual slope. Now, that's great if the points are very small. Okay? But what if they weren't? What if the numbers were 33 and 51 and -102 and 12? Then I don't want to do this because I don't want to have to plot those on a graph. Okay? What do? Now I need another way to do it. Okay? And that other way to do it is, and I'm going to use these same points. We already know the answer, so I'm going to use these same points, -1, 2. And we already know that the slope is 3/4. But what I'm going to use is something called the slope formula. And this is huge, okay? This is one of those things that I would love for you to commit to memory. I'd love you to memorize it because it comes up again in a bunch of different ways. When we see point slope form, it's going to come up again. When you start to do something called the distance formula, you're going to see this again. So this is one of those things that like sneaks back into your math lessons over and over again. So the sooner you understand it, the better. And here it is. Slope. We abbreviate slope with the letter M. Why the letter M, you say? It comes from the Greek word for mountain, because that's where they thought about a slope as some mountainside. So they use mountain. So really, that's why we use the letter M. Also, S's are terrible as letters because they look too much like 5s. So we tend not to use S to represent anything. The only thing I know we use it for is sometimes we talk about sides, and usually that's only on a square. But I still don't like it because it looks too much like a 5. So M is our mountain. On the top, we do Y, and then there's a little sub 2. What does that mean? I'll show you what that means in just a second. Minus Y1, and I'll talk about, again, what those 1s and 2s mean. Divided by X2 minus X1. Now, what are all these little 1s and 2s? Well, I was given 2 points, 3, 5, and negative 1, 2. Every ordered pair you ever see is X, comma, Y. X, comma, Y. Every ordered pair, they're always listed this way. Never changes. Now, what are these little 1s and 2s? They're just, which ones of these are 1 and 2? This is the first point. I will call this point number 1. Why? Because it's the first one. And this one will be number 2. And that will mean that this X would be the X1. And this Y would be the Y1. Those are the X and the Y of point 1. And you can follow along that this means this is the X2 and the Y2. And if I had a third point, I'd have an X3 and a Y3. And if I had a fourth one, I'd have an X4 and a Y4 and so on. Okay, that's just, these are little designations. They're not numbers in the sense that they have value. They are more of a designation that this is the Y value from the second point. So now I'm going to plug in the numbers, and it's just arithmetic. So the Y, the second Y value, that's the number 2, minus the first Y value, that's the number 5, divided by the second X value, that's negative 1, minus the first X value, that's the number 3. Now this is all that little, got to be careful, got to watch your signs. Mistakes happen frequently that are sign-based here because it's not the arithmetic, the numbers are very small. But this is also where I love queso. I love to put a little cheese on it, as you guys remember. I love to keep that first number. I love to switch this to addition and change this to its opposite. 2 plus negative 5 is negative 3. Then I like to do it again. Keep this negative 1. I'm going to switch this to addition, and I'm going to change that to a negative 3. Negative 1 plus negative 3 is negative 4. A negative divided by a negative is a positive. We already knew the answer was 3/4. But there it is, 3/4. Positive 3/4. Okay, now the advantage the graphing gives us is that we could see by looking at it that that was going up and it was a positive slope. I remember the graph, right? We real quick, just kind of throwing it down one more time. 3, 5, and negative 1, 2, look like this. I can see this is going up from left to right as my eye tracks that way. So it helps me understand what the right slope, the slope of the sign, the sign of the slope. The sign of the slope has to be a positive number because it's going up from left to right. Okay. So that's one of the advantages that graphing gives us. It also lets us count. It's much easier to count than it is to do maybe this math, especially if you're one of those people that's still struggling with the positive negatives. So that's the advantage that graphing gives us. But again, what if, and I'll do one that qualifies as a what if here in just a second here, because there's going to be that what if there was no chance that, and I hope you didn't hear it, you probably heard that, but there's no chance that I can graph it because the numbers are just too big, or even worse, they're like fractions or decimals or something horrible. Okay, I don't want to try to plot 10.13 on the graph, but I could certainly I could certainly subtract from 10.13, for example. Okay, so let me give us, ooh, I'm going to put that back. We're going to do, so x2 minus x1. And again, hoping that you'll commit this to some form of memory, because you're going to see this again when we see point slope form in about, I don't know, 4 lessons, 3 weeks, 4 weeks, I don't know, something like that. So what if the numbers were not cooperative? What if they were 22, 51 and negative 3, negative 11? Ugh. I don't want to deal with that. I certainly don't want to graph it. I don't want to put 2251 on a graph. Okay, what do? Okay, well, I have this nice equation here, and I'm going to let you in on a little secret. which one you call 1 and which one you call 2 do not matter. Remember I said it didn't matter which point we started from, which point we went to? So sometimes you'll start to look at it and go, you know what? I think I'm going to make that one count as 0.2, and this one will be 0.1, and I'll do it backwards. It doesn't matter. As long as, and here's the key things, y's are on top and you're subtracting, x's are on the bottom and you're subtracting. That's what really is going to stand out here. So, one example. So here we go. I'm going to grab the y value, 51, minus negative 11. Again, 22, minus negative 3. And this is where queso is your best friend, because when I do the queso part, 51 minus a minus becomes plus. 51 plus 11 is 62. Minus a minus becomes plus. 22 plus is 25. And you know what? That's ugly. I don't even want to reduce it. I'm not going to. There's no common, nothing. There's no. This is only divisible by 5. This is not. I'm done. I'm done. No God, no mixed numbers, no decimals. Improper fractions are perfectly fine. Okay? Absolutely fine. If you get negative and negative, then you do want to turn that into a positive, because if they have the same sign, they're positive. If they have different signs, they're negative. And it doesn't matter where the signs are. Signs are the same, it's positive. If the signs are different, it's negative. Okay? So this, I would not want to graph. That's why I want to have this. I mean, I could even go one step further, and what if these were 22.3 and 51.7, make them just awful? I don't want to do that. That's just extra pain. Okay, so we want to stick with this the way it is, and I hope that you can ignore all of those little buzzers, and I will see you in class or in office hours.